So after we go through EVT, it's very natural to do what's called a first derivative test. Now, you need to do the first derivative test, and its procedure is very similar to EVT. That's why it's kind of natural for one to follow the other. You need to do the first derivative test when you're trying to determine your local mins, maxes, if your function's increasing, decreasing. So in your homework, textbooks, workbooks, even AP exam, if you're ever asked to find where your function's increasing or decreasing, you go through this procedure. How you state your answer, please make sure you state your answer as we said. It tends towards recently that it's not whether, okay, your function's positive or increasing, negative, it's decreasing, it's rather the sign of your derivative. So you have to say if it's positive, it's increased, your function's increasing, negative, your function's decreasing. So we're going to go over that to make sure that you state your answer correctly, go through all the steps so you can get full credit on this type of question. Okay, so with that being said, there's a whole bunch of steps, and I know it's not A through E. It's a little bit longer doing A through H. So please jot it down, please write it down, and we're going to go through each step. It's really important that you know what each step is, so if you don't copy the procedure, you're not going to know what it is. So if you have to stop, pause the video, make sure that you copy your notes. Okay, so our example asks us to find critical points and our local extreme values and if our function's increasing or decreasing. So this is what I said, we need to go through the whole first derivative test. So there's a new part A, okay, and part A is to find where f is not continuous. If it is continuous, then we would state that, and that's actually the case for part A. If you look at your two expressions that are being multiplied to give us f of x, they are continuous. So f of x is continuous for all reals. State that. Otherwise, you really can't proceed to actually do an analysis and do the first derivative test. All right, if it's not continuous, then state where, okay? Make sure you do that step correctly. B. So we're finding f prime of x. This is like the first part that we do with EVT. So since it is two things that are being multiplied, we need to do the product rule. That's not a -3. First derivative of second plus second derivative of the first. Okay, you may want to make that a little bit clearer, maybe switch around terms or factor out an e to the x, but you don't have to yet. Let's move on to C. So this is where we look at f prime of x to see where it's not defined to find any critical points. Okay, so if f prime of x is not defined, that means it's non-differentiable. But if you look at our function, okay, e to the x is differentiable at every x value, so it is like 2x or x squared. So we can say that f of x is differentiable for all reals. Okay, so you can look back for when we did an example with EVT for where we found where it's non-differentiable. Just in this example now, it is differentiable. Now let's do part D, and I'm kind of running out of space here, so I guess I'll erase A and B. So part D. So we want to set f prime of x equal to 0 to find any other critical points. If we find anything here, these are our only critical points. So let's do our derivative equal to 0. And like I was saying, maybe factor. So if you do factor out an e to the x, then we can set e to the x equal to 0, and our factors from the polynomial here equal to 0. So if we write this in ax squared plus bx plus c order, we can easily factor this. Okay, and then set each factor equal to 0 to solve. Now, over here, we can't solve x is greater than 0, so there's no critical points here. But luckily, because we do actually want critical points, we solve these here for each equation, and we find that there are 2 critical points. When x is equal to -3 and when x is equal to 1. So now we're up to part E, and this is where it gets interesting. So E is interesting because it's different than we've had before. So I kind of insist on making a chart, or at least a clear outline, where you label what your intervals of x are. And so we have a continuous function. We're looking at when x equals -3 and 1 as critical points. So you're splitting up your x-axis, if you want to say, into the correct intervals. So that means your lowest number has to come first and your highest number has to come second. So that we can plug it in to f prime of x. When we do, we don't actually need the value, but we need to determine what sign we get. So if let's take -4. If I plug -4 into f prime of x, little reminder here, this is our rewrite for f prime of x. Okay, so we end up getting, let's say, 16 minus 8, so 8 minus 3 is 5, times a value for e to the -4th power. Now, e to the -4 is still going to be above the x-axis, so this is a positive answer. I don't need to have an exact value. You just have to determine your answer. You should not get 0 as an answer, by the way. All right, if I plug in 0, I would get a negative answer. And when I plug in, let's say, 2 or 2 billion, I would get a positive answer. Okay, so just kind of take an analysis of your function for f prime of x. And then what do we know? We know the behavior of f of x. Okay, so this is important. So we know it's increasing here because of the sign being positive, decreasing there because of the sign being negative, and increasing here because of the sign being positive. So we're kind of identifying, but we didn't state an answer, so always state that answer later. Okay, so we actually did E and F and G already. Believe it or not, you copied it down. This is what we're doing. So let's do H. We'll write out our answer, and then we're good to go. Okay, so H. F of x has a relative maximum at x equals -3 because f prime of x changes from positive to negative. Okay, and this is what I was describing before. It's always about the sign change for f prime of x. Okay, that means your function was increasing to decreasing. Don't state that. Okay, and f of x has a relative minimum at x equals 1 Okay, and please don't write it instead of f of x because people are not going to know what you're talking about. Okay, you need to state it's f of x, not f prime of x or g prime of x or anything else. All right? So it's -1 because f prime of x changes from negative to positive. So our function was decreasing then increasing. That gives us a relative minimum. So we found the critical points. And if you want, you can just clarify that was x equals -3 and 1. And we just wrote out our whole detail for the local extreme values. Relative is another word for local. And it asks for the intervals where f is increasing. So f was increasing on the intervals of -infinity to -3 or 1 to infinity, and it was decreasing on the one interval from -3 to 1. Okay, so that details everything. Our first derivative test helps us out, and I just want to wish you good luck on your practice.